how to calculate the maximum number of electrons. We are still on quantum numbers, right? Now, most people already know this formula. If I say what is the maximum number, for example, let me say n is equals to 7, and I say what is the maximum number of electron in this, given that your n is equals to 7. A lot of people already know this formula, 2n squared, right? And so this is 2 into 7 squared. This will give you 49, and then 49 times 2, that should give you 98. So a lot of people knows this formula already. It's so easy, but then we want to go in depth. It's not every question under this topic that this formula can solve. So I want you to start visualizing it so that you can understand it properly, so that however the question is being asked, you can be able to answer it. Now let's go. From the introduction of the video on our channel already, remember I said if n have 1, we already said that the number of shell, if the energy level is 1, the number of shell is 1. I mean just 1x. From electronic configuration, you should know that. And if m is 2, that means we have 2x and what? 2p. And then this is the energy level. I said something when I started the video that if you have this, and I ask you, this hydrogen, how many energy level does this have? This is n is equals to 1, this is 2, this is what? 3. That means we have 3 energy level. The same thing is happening here. If the energy level is 3, that means here you have 3x, 3p, and what? 3d. N is equals to 4, you have 4x, 4p, 4d, and what? 4f, right? Good. And so, what if, and now, should in case I ask you, calculate the maximum number of electrons, don't use this formula, use the conventional method like this to calculate it. Of course, you should know if this is n is equals to 1, that the maximum number of electrons that the s will carry, or that this s shell will contain, is what? 2. Now, from here, what's the maximum number of electrons? If the energy level here is 2, don't use this formula. You can see this, the maximum number of electrons the s will contain is 2. The maximum number of electrons p will contain is what? 6. So the total number will be what? 8. Here we have 2, we have 6, and we have 10. And so the total number, the maximum number of electrons this will contain, if the energy level is 3, will be what? 18. If you use this formula, you still get the same thing. I want you to start understanding this topic very well, because every other example I'm going to be dropping after this, you truly do not need this formula. And with just that formula, you cannot solve it. Now let's proceed. What if your n is 5? So we have 5s, 5p, 5d, 5f, and 5h. And of course, this is 2, 6, 10, 14, and what? 18. Because like I said, they increase by what? 4. So the maximum number of electrons, if your n is equals to 5, should give you what? 50. If you use this same equation, you will get it. I'm taking my time so that you understand what I'm saying. Now, let's go to example number 2 proper. Then let's see how it is. Now, number 2, what is the maximum number of electrons given this set of quantum numbers? N is equals to 4, ms is equals to half plus half. And of course, from my videos, the earlier videos, I already explained what is n, what is ms, and what it means for ms to be plus half or minus half. Now, this question is, what is the maximum number of electrons given that n is equals to 4 and ms is equals to plus 1 all over 2? Now, remember, if the energy level is 4, that means if n is 4, that means we have 4s, 4p, right? 4d, and what? 4f, right? I want you to understand this so easily, and so that we can move or progress naturally. Now, remember, I want to write this like this. We have 4s because I want to draw the shell. 4p, 4d, 4f. And you already know that this, we have one soft shell here, or one orbital, and this we have the number of soft shell in p orbital is 3. We have, let me draw it. We have 3 soft shell, and here you already know that we have how many here? 1, 2, 3, 4, 5, and then we have 7 here. 7. And so, let me draw a box here. We want to calculate the maximum number of electrons given to these two set of quantum numbers, right? Now, remember, the highest number of electrons S will contain here is 2. And here, remember, they will go singly first before pairing, right? The same thing is happening here. Go singly before pairing. So, please note the way I'm putting the arrows. One is up, one is down, right? Good. Now, the total number of electrons that is contained here in this shell is 32. Count it. You should know that is 32, right? Now, but they did not ask you to calculate, because if you use 2n square right now, 2n square, you see that this is 2, n is 4, so this should give you 32 electrons, right? Now the problem is they did not ask you to calculate the maximum number of electrons, giving only n. They gave you n and mx. Now, using the conventional method, you can see this is the soft shells, and we've already filled in the maximum number of electrons these shells can contain. Now they are only interested in the electron that have the up arrow, not the down, because the ms value is plus half. That means they are only interested in the arrow that is what? Upwards. Now this is 32, and of course 16 are upwards, and then the rest of the 16 are what? Downward. So because of this ms, they are only asking you that we need you to count those numbers of arrows that are what? Upward, not downward. And so the maximum number of electrons given these two quantum number is what? 16 electrons, and that's the answer. That is the answer. Let's proceed to another example. The more I solve, the more you end up, not me, you end up getting the gist. Now, if, let's say, number 3, your M is 4 and your L is 2, and I ask you, what is the maximum number of electrons given these two set quantum numbers? This is the third case. After 7 cases, I'm telling you, there is no any question on this kind of topic that you are ever going to fail. It's not possible. Now, we have these two quantum numbers set. N is 4, L is equals to what? 2. And I ask you, what is the maximum number of electrons given these two quantum numbers? Now, please, there is a trick here. Remember, see the way I'm solving this thing, because you never can tell which among the quantum numbers they will give you. So whichever one they give you, please, there is a different way of solving it. So follow the video closely. And so if you have N is equals to 4 and L is equals to 2, remember the L always gives you the what? The shape. And your L will start from, remember when you have 0, 1, 2, and what? 3. And we said this is the value for your L. Whenever it's 0 is S, P, D, and what? F, right? Good. Now, the next thing is, if L, this is S, P, D, and F. If the value assigned to L is 2, that means we're talking about the d orbital. And remember, do you remember that video when I was doing 4p2 and I asked you to bring out the 4 quantum numbers? You already know that here is what? The n, right? Good. So they have given you n. So automatically what I want to do is, this is 4 and your L is 2, so this is what? D. Now, what is the maximum number of electrons D can contain? The maximum number of electrons D can contain is what? 14. If you want to do it conventionally, D has 7 subshell, right? And so this is 1, 2, 3, 4, 5, 6. So electron will enter singly. Before pairing, right? And so this will give you a total number of what? 14 electrons. And so that is how to determine, given those 2 quantum numbers. Let's go to please, what am I doing? This is D. This is D, not F. I was solving with D. This is D. So the maximum number of electrons D can contain is 10. I was saying is 14. So this should give us 5 shell, not 7. I was doing that of F. So this should give us 5. This should give us 5 shell. So the total number of electrons should be 10, not 14. Not 14. So this will be 10 electrons. If I want out of the 14, all I have to do is, we'll say n is equals to 4. Let me solve it since I already did the video. N is equals to 4, and then your L is equals to 3. This is example number 4. And as what's the maximum number of electrons here? Of course, if your N is 4, your L, which is 3, should be what? F. The maximum number of electrons in F is 14. If you can draw it like just as I just did, this was what I solved here. That was not correct. That's why I'm explaining it. Sorry about that. So 1, 2, 3, 4, 5, 6, and this is 7. So the maximum number of electrons given those 2 quantum numbers is 14. Given this, the answer is 10 electrons, please. Sorry for that small mistake. Let's go to the next example. Example number 5. What's the maximum number of electrons when you have n is equals to 4, ml is equals to 1? Please pay attention here. This is the interesting part. So, of course, by n being 4 and ml being 1, of course, we have 4 energy level. And like I said, this is very interesting. But this question, do you see the way I'm solving it differently? That is the way you can actually learn it and solve it differently. It doesn't have one single method of solving. That's one tricky thing about this topic. Now, whenever they give you L and N is equals to 4, ML is equals to 1, you have to change another method of solving. How? This will not be, remember when N is 4, we already said it, we have 4x, 4p, 4d, and 4f, right? Good. This is under the L, these are the under N. Let me write N here. The next thing is L. We were not giving L, but you have to create a table for L. So this is for L. Remember I said when L is 0, we're talking about the S. 1, 2, and 1, 3. When L is 0, we're talking about the S orbital. When L is 1, we're talking about the p orbital. When L is 2, we're talking about the d orbital. When L is 3, we're talking about the what? The f orbital. Now, the next thing, remember, what you have to do L is there cannot be ML without L. And so if the value of L is 0 here, remember this is your ML table. So whenever L is 0, and of course your ML is always 0. We don't have minus and plus, minus 0 plus 0. 0 is 0. So if your L here is 1, your ML is minus 1, 0, 1. Here is minus 2, minus 1, 0, 1, 2. Here is minus 3, minus 1, 0, 1, 2. Let me separate this column. This is for L, this is for M. Look at the table here, right? Good. Please pay attention. We want to calculate the maximum number of electrons. We only have M and ML. So what they are asking you is, what is the maximum number of electrons? This 1, look at ML is equals to 1. So they have already specified the shell or subshell for you. And so remember, here we have 1, here we have 1, here we have 1 here. So let me circle it. Remember, if S orbital, we have 1 orbital here. If it's P, we have 3 orbitals here. If it is D, we have 5 orbitals. 1, 2, 3, 4, 5. If it is this, we have what? 7, right? 1, 2, 3, 4, 5, 6, 7. Now, they want you to calculate the maximum number of electrons this shell that contains 1, 1, 1 will contain. Remember, here is minus 1, 0, and 1. This place is minus 2, minus 1, 0, 1, and 2. This place is minus 3, minus 1, 0, 1, 2. What am I doing? Minus 3, minus 2, minus 1, 0, 1, 2, and 3. Now they want you to know what's the maximum number of electrons here will contain, here will contain, and then here will contain. Of course, the maximum number of electrons here will contain is 2, here is 2, here is 2. So the total number is what? 6. So the answer is what? 6 electrons. That's the answer. I'm taking my time to explain it for maximum comprehension. And so let's go to example number 5. Example number 5. So you can see that the method I used to solve this is not the same method I used to solve when L is 3 and L is, let's say, 2. What's the maximum number of electrons? They are not the same. And so you have to know different way of solving it. That's why I said it's simple, but it can be trickish. Example number 6. Example number 6. What's the maximum number of electrons given that N is equals to 4, L is equals to 3, ML is equals to minus 1. Now we have 3 orbitals, and they want us to calculate the maximum number of electrons. Right? Good. Now, let me clean this. So the first thing we're going to do is we have to bring it out. Remember, if I close this one, it becomes easier to solve, is it not? Because here you just know this is 4. Of course, you know S, P, D, F. This is 0, 1, 2, and 3. And so if L is 3, that means we're talking about F orbital, right? So this is 4F. But the problem is we don't have 2. We have the 3 quantum numbers. And they want us to calculate the maximum number of electrons in these 3 quantum numbers, not these 2 quantum numbers. If I didn't think the question was just 2 quantum numbers, the answer automatically is 14. Now, they want us to know what's the maximum number of electrons in these 3 quantum numbers. So we are succeeded in bringing out 4F, right? Then the next thing is we have to draw it. Of course, remember, this gave us this. L to be equals to 3 gave us what? F orbital. And so remember, your ML is always minus 3. Let me even draw it. If we are talking about the F orbital, right, it must have 7 subshells, right? So this is 1, 2, 3, 4, 5, 6. And so that means your ML is minus 3, minus 2, minus 1, 0, 1, 2, and 3, right? Good. Now, the next thing is they want to know what is the maximum number of electrons. What is the maximum number of electrons that have those 3 quantum numbers? And you have to stop at ml to be what? Equals to what? -2. So if the maximum number of electrons this will contain is 14, right? What is the maximum number of electrons this orbital, which is, look at it here, at -1, what is the maximum number of electrons this only orbital here will contain? Is 2. Because if it enters singly, you pair the maximum here can contain is only 2 electrons. And so the answer is simply 2 electrons. That's all. Are you getting it? Good. Example number 7. Example number 7. Example number 7. What's the maximum number of electrons when you have n? Example number 7. N is equals to 3. L is equals to 1. Mx is equals to plus 1/2. Not plus or minus. Keep on making silly mistakes today. Plus half. Now, of course, by here you already know our normal national anthem, SPDF 0, 1, 2, 3. So you have 3. L is 1, so we're talking about P. Now, they want us to know what's the maximum number of electrons with MS. So that means I have to draw it. P have 3 subshell. 3 subshell. And so you have here the maximum here. Alright? So, if Mx is, because the maximum number of electron 3p will contain is 6. Now they want us to know how many electrons we have the upward arrow. This is 6, so it's only 3 electrons that have the upward arrow, and so your answer is what? 3 electrons. This is now getting more easier now. The answer is now 3 electrons. Example, this is example number 8, right? I wrote 7. Now let's continue. If you have n is equal to, let me blend this. If your n is equals to 4, L is equals to 2, and your ML is equals to 0, right? And ML is equals to 0, and your MX is equals to minus 1/2. Let me give you a trick about this. Whenever you have the 4 quantum numbers and they want you to calculate the maximum number of electrons, the answer, don't waste your time solving it, the answer is just 1 electron. Why? Because the whole 4 quantum numbers are already out. They're talking about a one particular electron. It's just like someone telling you, you come to a place and you say, okay, I stay in Alakaya. But in Alakaya, or there is a lot of lodges there. You have not specified is lodge. What's the name of your lodge? You have not said, you just said, I stay in Alakaya. But then, what if you tell somebody, I stay in let me say, House on the Rock, a lodge called House on the Rock in Alakaya, and my room number is 12. There is only one particular room with a room number 12 in House on the Rock in Alakaya. So this is the 4 quantum numbers, and therefore they specify the whole number, so they must be talking about a one particular electron. So whenever you have the 4 quantum numbers, your answer is just 1 electron. Don't waste your time. Don't waste your time. You can use the conventional method and also get the answer quickly. Let's go to the next example. If your n value is 4, your ML is 1, and your MS is -1/2. And of course, you should know this should give you 4. Now, we don't have L. Good. I love this question. We don't have L. Now, what are you going to do? What you're going to do is the same thing we have done before. So this is 4x, 4p, 4d, 4f, right? And so this is your n column, this is your l column, 0, 1, 2, 3. Then the next thing is your what? Your ml, right? We have 0, minus 1, comma 0, comma 1, minus 2, comma minus 1, comma 0, comma 1, comma 2, minus 3, comma minus 2, comma minus 1, comma 0, comma 1, comma 2, right? Good. Now, remember this is in table. Now, they want us to know what is the maximum number of electrons that have a specific ml orbital. At here, ml is 1. We have done something like this before. So there are 3 here, right? So the maximum number of electrons under ml equals to 1 is what? 6 electrons. But then, remember, they have upward and downward spin. And so, which of them have downward spin? That must be half of 6. So your answer is what? 3 electrons. And that's the answer, please. That is the answer. So that's all for this video. It's not that hard. I'll give you a classwork and that should be all. Now, what is the maximum number of electrons if you have n is equals to 3, L is equals to 2, and what's the maximum number of electrons for this? That should be all for this video. Thank you very much.